deep in our native solar system, we have in for our habitable planet Earth important star, our native home star Sun. The composition of the photosphere of the Sun is mostly made of hydrogen and helium. Well, nitrogen, iron, magnesium, carbon, oxygen, silicon, sulfur, and neon are the smallest contribution to the composition in our photosphere. Nowadays, we don't know exactly which kinds of minerals can be beneath the surface of our native home star Sun. From the galactic center of our Milky Way right now, our calculation says that the Sun orbits the center of the Milky Way at an approximately distance of 26,000 light years. From our native habitable home planet Earth, we see our Sun 8 minutes in past because light needs around 8 minutes and 70 plus minus seconds to reach our planet. In our eyelight, please take in mind not to observe the Sun without solar filter because it can make you blind. For more information, seek medical and physical consulting. The radiative fused nearby perfect sphere of hot plasma heated to incandescence by the process of nuclear fusion in our native home star's core is radiating mainly visible light. Approximately 10% of its radiation is rayed out as ultraviolet energies. You know from your display activity one popular but more hated ultraviolet energy, the blue light emission. But in comparison to a dark-room computer activity with a specific blue light emission, the Sun's main blue light ultraviolet emission, our Sun's blue light is essential for our melatonin reduction to stay awake and productive. The density of the Sun varies exponentially, not only decreases, we have also phases where the Sun also increases her density. A reduction of density is achieved through the incremental increase of height above the own photosphere. In my point of view, while our native solar star has an impact on our planet's magnetic field with guiding support through the heliosphere, which is around our solar system, the Sun also has some kind of heliosphere combined with the sun winds. They all contribute towards the efficiency of one another. Some studies from 2003 of specific universities claim that the tidal effect of the planets is weak. I would say while the dark matter in our solar system, as so the magnetic field and the heliosphere is contributing to our solar system's balance, as so to the rotative ellipse of our planets around the star. Our native star impacts the planets, and otherwise our planets impact our native star. All in one together with additional aspects from other astrotopics are leading to a more safe and stable flow of our solar system's ellipses of celestial objects. Trabants, also known as moons of planets, are mostly impacted by the planet's magnetic field and its gravitational force. Out there we have also specific stars who don't have a single planet and celestial object. They are meant to gather elements. We already observed specific stars which are in states of a red giant, planetary nebula, white dwarfs and many more. They all have common denominators but not exactly the same in common. Each star is a unique counterpart to another star. While we inspire through other stars what could be exactly with the life cycle of our star and spread theories about it, we don't have yet proved claim that the life cycle of the stars that we observe have all something in common, or if there could be different life cycles for specific kinds of stars out there. A collapsing protostar until a red giant must not also be the same claimed life cycle for our own native solar star. So of all of that, the researchers on life cycles of stars could be more precise. As so, planets have many different kinds of minerals and elements, as so stars do. And the same counts for their own life cycle. Important terms of the Sun is the sunspot, which are penumbra and umbra at this moment. Granu, solar wind, corona flare, prominence, transition region, atmosphere, chromosphere, photosphere, convective zone, tachocline, radiative zone, and its core. Like said before, we don't know much about what's beneath the surface since we didn't research it precise enough. And we didn't do research on specific elements which can resist and protect inner core ships of remote machines as so robots which can enter the surface for more research. I have hopes that it will be one day possible and that we understand more about the functionality of our stars. We could figure out more about our astronomical view if we contextualize information gathered through astronomy, astrobiology, astrochemics, astrochemo, astrophysics, astroinformatics, astromedicine, astrotelemetry, astrogeography, and many other important commons. In other scientific interdisciplinary subsubjects of the astro world, stuff like astrophotogrammetry assists us in 3D API like already known in Celestia and many other presentation documentaries. I also use the 3D API rendered version with textures of the Sun's surface from Celestia for my project. Additionally, we can research with stuff like Cartes du Ciel, but they are more only meant for astronomy and a basic kind of understanding of the navigation and our view of universe. Machines assist us right now in measuring the perihelion and aphelion of celestial objects, but there could be more, and with remote robots we will create so much more job opportunities for anyone here. Right now we have popular solar space missions like Solar Maximum, Pioneer, Ulysses, and many more. Let's scale all this stuff up in a goodwill for all of us. At this moment, Central European Time Zone and our host, Germany 2025, November the 28th, 12:27:30 p.m. Our native star sun is less than the mean 1 astronomical unit for exactly 147,589,354 kilometers, which are up rounded 0.98656 astronomical units. The azimuth is from here 181 degree at 43 minutes and 80 seconds, and the attitude is plus 60 degree 33 minutes and 28.8 seconds from the visibility of the observatory of our house in Germany. What do you know about our native solar star, the Sun? Write it down in the comment section. You all are appreciated. Your username Lado.